This is Vaishak Chandra, and he will be teaching a lesson on Lewis dot structures. Go ahead, Mr. Chandra.
Good morning, class. So, last time we talked about valence electrons, last class. And, today we're going to expand on that subject a little more. And the first thing you're going to do when you get into class is you're going to take a seat, sit down silently, and I'm going to show you a little video. And as you watch this video, I want you to think about valence electrons and how they are the outermost shell of electrons, like we talked about yesterday, and also the different electron subshells, as we've mentioned before. And as you think about it, at the end of the video, it's about 30 seconds long, I want you to think about the answer to the question. I'm going to ask you this question. What are valence electrons, and how did this video show valence electrons and the different subshells of electrons?
Hello.
So, class, can anyone tell me how that video related to valence electrons and the different electron subshells as we introduced and talked about yesterday in class? Yes, Casey.
Well, just like there are different levels of the doll, there are different levels that electrons are found in.
Okay, so what exactly do you mean by different levels of the doll?
Well, there's an outer level, and then they keep getting smaller as they get in. So I guess the outer level is like the valence electrons, because that's the part that we interact with.
Okay, that's exactly right. So now if that outer level of the doll is represented by it represents the valence electrons in an atom. And we keep opening and opening and opening. What is going to be the smallest doll that we find? Can anyone answer that? Yes?
It would be the nucleus.
The nucleus, that's exactly right. And just to review from last class, can anyone tell me what exactly is contained in the nucleus? Yes, go ahead.
It's the, isn't it the neutrons?
Neutrons, that is correct. Do you remember anything else that's, that we talked about 3 subatomic particles, and there's electrons on the outside, and then, you're right, neutrons on the inside, and do you remember another subatomic particle?
Oh, the protons.
The protons, that's correct. And do you remember possibly their respective charges?
So the protons and the neutrons are in the nucleus, and the protons have the positive charge?
Yes, that's correct. Protons have the positive charge. How about the electrons and the neutrons? Can anyone help them out?
I don't remember.
Yeah, go ahead.
Well, the way I remember neutrons, it's the word neutral, so meaning they don't have a charge at all.
Okay, that's correct. That's correct. And what about electrons? Do you remember?
Well, they're the opposite of protons, so they have a negative charge.
Negative charge, yeah, that's exactly correct. So, since we've been talking about valence electrons, the next step that we're going to take is showing how these valence electrons are represented in Lewis dot structures. And the reason why we want to learn about Lewis dot structures is because valence down in step box 3, and then we're going to move on. Moving on to the next step. Step 4 is where we actually draw the entire valence, or the entire Lewis dot structure. So if we have this F, once again with 4 different positions, how many valence electrons are we going to draw again? We just found out in step 3.
7.
Yes. 7, that's correct. So, step 4 tells us, start from the top and draw 1 dot. And then, continue drawing 1 dot in each position so that a full circle is completed. Yes?
Why are we
question?
drawing dots?
Why are we drawing dots? It's a great question. Each of these dots represents 1 valence electron. So since Lewis dot structures, as is implied by the name, since we're trying to draw valence electrons and represent them in these Lewis structures. They're called Lewis dot structures, and thus each dot represents valence electrons. So as we were saying, we draw one dot at the top, and we draw one dot in a clockwise pattern all the way, making one circle without pairing each electron. Yes?
Does it matter if we do it clockwise?
Does it matter if you draw it clockwise?
Yeah.
To be honest, it does not matter in terms of, the final product. You might have, certain electrons on one side and your unpaired electrons on the other side. But for the convention and for this class, and in order for me to see that you got the right answer, I want you to go clockwise so that all of our answers are standard. So we've drawn 4 electrons in so far. Now we're back to the top, and it says that so a full circle is completed before pairing electrons. So now since we still need to draw 3 more electrons, since the number of valence electrons that fluorine has is 7, we'll continue and pair electrons until we have drawn a total of 7 electrons. So that is our final Lewis dot structure for fluorine. But before we finish, we need to check and make sure our rules are still intact for drawing Lewis dot structures, and we need to check that there's a maximum of 8 electrons. And as we can see, we've drawn in 7, so we're going to go ahead and check that off. And we're going to move on to the next example. So hopefully you followed along and understand, because I will be asking more questions in the next example to make sure that everyone in the class understands. So actually, for this example, can I have someone come up and draw, exactly, the next Lewis dot structure? Can I have a volunteer? Yes. You can bring your worksheet with you. Go ahead, stand right here. And the next example that we're going to do is phosphorus. So go ahead and look at your periodic table, and I'll tell you that phosphorus has an atomic number of 15 to help you out. All right, so you're ready? So go ahead and do step number 1, write the element symbol. All right, that is correct. Good job. And now, number 2, assume electrons can be placed on any of the 4 sides of the element symbol, top, bottom, left, and right. So go ahead and draw the P again.
So draw like the dashes like you
Yes,
did?
draw 4 dashes on each side. Correct. All right, now, can you tell us what are the number of valence electrons that phosphorus has?
Well, it's in group 15.
It's in group 15, that's
So
correct.
I dropped a 1, so that means I have 5.
That means you have 5, that is correct. So go ahead and write that in. Ray, can you tell me why she knew that there were 5 valence electrons?
Because it was in group 15.
Because it was in group 15, that's exactly correct. And before we talked about how if you're in group 13, 14, 15, 16, 17, or 18, you have 3, 4, 5, and all the way up to 8 valence electrons. So that's exactly correct. So, tearing this page off. Go ahead and draw the entire completed Lewis dot structure for number 4, following each of the different steps. So go ahead and...
So I draw the letter.
Correct?
And then I draw my placeholders.
Yes.
Then I put in my number of valence electrons.
The number of valence electrons, correct. So you start from the top, draw 1 dot. Go ahead.
Counter.
Clockwise. All right. So how many valence electrons did we need to draw again?
5.
5. Correct. So you've drawn 5. All right. So now that is correct. So now can we move on to number 5 and check for a maximum of 8 electrons? Do we have less than 8 electrons or 8 electrons at most?
We have less.
We have less. So we can go ahead and check that off. And we know that we have now, drawn a complete Lewis dot structure. And after